Hello, hello. I hope I'm audible. So we will start with the session now. So I welcome you all to the 10th week live session on the course Integrated Waste Management for a Smart City. So this is the NPTEL live session for the 10th week of this course. I am Abhishek Raj, PMRF scholar in the Department of Civil Engineering, IIT Madras. So firstly, we will see the overview for this session. So the overview of week 10, what were the topics that were discussed in week 10. Followed by this, we will see the questions in the practice assignment. So there will be around 12 to 13 questions that we will discuss, and then we can take on some doubts if time permits. So moving on to question number. So moving on to the overview for week 10. So firstly, we have lecture 1. So this was about the construction process, mostly regarding the drawings, permits, what are the official processes that are done during construction. Then we discussed the topic of leachate generation, how it is, how the calculation is done for the amount of leachate that will be generated. Then second lecture was about the waste decomposition basics. So how does the waste degrade? What are the components that are required for degradation? What are the components that will be produced on degradation? Then we have the landfill gas generation. So how do we determine the amount of gas that is generated? Followed by this was lecture 3. So lecture 3 was about the C&D waste management rules of 2016. So similar to the municipal solid waste management rules 2016. These rules are there for the management of construction and demolition waste. So this defines the duties of the different stakeholders. So who are the stakeholders? So firstly, we will have the people who generate the waste generators. We can have local authorities. We can have the State Pollution Control Board. We can have Central Pollution Control Board. We can also have the state government institutes such as IRC are also involved with C&D waste. Then lecture 4 was about the C&D waste components. So what are the components in C&D waste? So it can be used up concrete, wood, gypsum, and so on. Then the options for management. So where all we can use these waste components. Then lecture 5 was about the recycling methods. So what are the methods that are used for recycling of the different C&D waste components? And finally, we had lecture 5. So it was about the hazardous C&D waste such as asbestos. So now we will move on to the first question. So question number 1. So this is the poll. So assume a cell of a landfill. So the image will be provided where all the naturally occurring phenomenon is happening. What will be the amount of leachate that will be stored in the leachate well, where P is precipitation, S is runoff, ET is evapotranspiration, and delta S is the stored leachate within the landfill, and L is the leakage. So we have been given the options P plus L minus of S plus ET plus delta S, P plus ET plus S plus L plus delta S, P plus delta S minus of ET plus S plus L, and finally we have P minus the sum of ET plus S plus L plus delta S. So this is a poll. So I will drop a poll in the Gmail. You can also answer it in the chat. So this is question number 1. Plus 4 options. Launched the poll. You can also answer it in the chat. I'll give you maybe 2 to 3 minutes for this. So we don't have any response as of now. I'll wait for 1 more minute and then we can discuss the answer for this. Maybe we can discuss the answer for this question since we don't have any responses. So we have been given the cell of a landfill, which can be seen in the figure here. So there are certain inputs to the system and there are certain outputs, and depending upon that, we need to find the amount of leachate that will get stored in the leachate well. So that is nothing but QL here. So let's first indicate what are the inputs. So the input will be precipitation. It is indicated by P. So what will be the outputs? So there can be certain runoff. So that is indicated by S here. There can be some evapotranspiration from the vegetation growth that happens on a landfill. So that is ET. Then we will have some leakage L. Although it should not happen, we will assume that some leakage is happening for being conservative. Then we can have some storage within the landfill for the moisture. So that is indicated by delta S. So how will we do this? So we will add up all the inputs and then we will subtract the sum of all the outputs, and this should be equal to the storage. So whatever went into the system and whatever went out of the system, we are subtracting that, and that should be equal to the storage. It can be positive or negative depending upon the inputs and outputs magnitude. So here we have precipitation. Then let's take the outputs. So we have S plus ET plus L, and this should be equal to delta S. Along with this, we will also have the output, which will be the leachate. So we have the leachate, so that would be in output, so that we can write it as QL. So we can add QL here. So summation of the inputs minus summation of outputs equals to the storage, so that will be delta S. So from here we can get QL as, let's take everything on one side, so it will become QL equals P minus S plus ET plus L and plus delta S. Let's check it once. So we took QL on this side. So basically the discharge or the amount of leachate that is generated from a landfill will be equal to the difference of the precipitation that is happening minus the runoff, evapotranspiration, leakage, and the amount of storage that is happening within the mass of the landfill itself. So by comparing the options, we can see the answer to be option D. So I hope this was clear. I'll just quickly repeat it. Someone joined. So we have the input to the system, so that is precipitation written here. Then we have the outputs, so that will be runoff S, evapotranspiration ET, some leakage L, and there will be some amount of leachate that will get generated and stored in the well, so that is also our output. So we have S, ET, L, and QL, and then there will be some storage. So the sum of inputs minus the sum of the outputs should be equal to the storage within the landfill. So then we substituted the values and got the value of the leachate generated, which is QL. Moving on to the solution. So you can see the solution here. Option D is the correct answer. So leachate generated is equal to precipitation minus evapotranspiration plus runoff plus leakage plus storage. So students can refer to the first lecture of this week for this question. So here it can be seen. You should add up all the inputs minus you should subtract all the outputs, and this will give you the change in the storage. So moving on to question number 2. So which of the following definition represents field capacity? The volumetric water content where plants can no longer draw moisture from the soil. The summation of the change of water from its liquid phase to its vapor phase and evaporation occurring through the plant leaves through stomatal opening. The amount of liquid that a given mass of waste can absorb prior to downward percolation of the liquid due to gravitational forces, and then we have none of these. So some response. So C, okay, that is correct. So still we'll discuss the answer. So the volumetric water content, let's take each option one by one, where plants can no longer draw moisture from the soil. So this is called as the wilting point. This will be called as the wilting point. So this will be like the point where the soil will get almost dried up and the plants will not be able to survive. So this will be like a minimum moisture level within the soil. So basically, we draw the moisture on y-axis and we have, let's say, time on the x-axis. So I'm giving an example from irrigation. So there will be certain point called the wilting point, then there will be the field capacity. So initially we will irrigate the field, so the moisture level will drop to the wilting point. Then we will irrigate the field again after some time, let's say 10 days. So it will again go up to the field capacity. Again it will drop, again it will. So this cycle keeps on going. So before it goes to wilting point, at some level in between, we should irrigate so that the growth of the plants don't get hampered. So that is the wilting point. So at this point, the plant will not be able to survive and it will die. Then there is the summation of the change of water from its liquid phase to its vapor phase. So what is this? This is nothing but evaporation, and the evaporation occurring through the plant leaves through the stomatal opening. So this is transpiration. So they are asking about the summation of both. So this will be called as evapotranspiration. So indicated by ET as discussed in the first question also. So then we have the amount of liquid that a given mass of waste can absorb prior to downward percolation of that liquid due to gravitational forces. So yeah, this is correct. This is called as nothing but field capacity. So this is the point where, let's say we have a soil sample. We supply water. So it will have air pores, so that will be able to hold up the water up to certain point. So once these air pores get filled up, after that the water will start draining out. So the level of water content at which this happens should be called the field capacity. So that is the definition. So option C is the correct answer. Moving on to the solution of the second question. So the amount of liquid that a given mass or volume of waste can absorb prior to downward percolation of that liquid due to gravitational forces. So this is refer to the first lecture of this week. So that is field capacity. So I gave the example of soil in the question. So you can use it similarly for waste also, because in landfill we'll cover it with soil also. So it's the same. So it is the amount of liquid waste can absorb prior to downward percolation of liquid due to the gravitational forces. Moving on to question number 3. So what is the material that contributes most significantly to anaerobic waste decomposition in municipal solid waste landfills? So the options are glass, food waste, rubber, and metals. So can I quickly have some answer for this in the chat box? Okay, cool. So we are talking about anaerobic waste decomposition. So the first requirement for this should be that the waste should be organic. Anything inorganic cannot be easily degraded by microbes. So glass is inorganic, so we can remove this. Then we have metals, so that is also inorganic, so we can remove metals also. Then we have rubber. So rubber is originally organic, but it is mixed with certain uh, solvents, or you can say chemicals. So it kind of becomes inorganic. So it is not easily degradable. So we can remove rubber also. We are finally left with food waste. So very clearly we know that food waste will be organic. So food waste will contribute most significantly to the anaerobic waste decomposition. Along with food waste, we can have some cardboard waste or paper waste also. So that also increases the microbial activity. So option B is the correct. So we'll discuss the answer using the slide also. So food waste, option B was the correct answer. So students can refer to the second lecture of this week for this question. So what is the material that contributes most significantly to anaerobic waste decomposition? So that is the readily biodegradable components, which will include paper, cardboard, and food waste. So there will be some other components which can take longer time to break down, such as wood or leather. Moving on to the next question, question 4. So this is a poll. So which of the following equation represents the most used first order decay model for solid waste in landfills as part of the landfill gas estimation? So the given options are mt equals m naught into 1 minus e to the power minus kt, mt equals m naught e to the power kt, mt equals m naught e to the power minus 1 by kt, and finally we have mt equals m naught e to the power minus kt. So since this is a poll, drop a poll quickly. So you can answer it in the chat also. Okay. I'll give maybe 2 to 3 minutes for this. Someone has answered it. Okay. Session. This is the population of the and use the fish to get that. It can be possible, let's say, train that able to came on the Any other responses? Let's check the poll. We have one response for you. Give one more minute. Check the answer. So we are concerned with the mass of solid waste within landfills. The degradation is happening using first order decay. One answer for me. Let's see the answer. So we have the first order decay model for solid waste in landfills as part of the landfill gas estimation. So let's see what this first order decay model means. We'll see this from scratch. So let's say the initial mass. So let's say this is a schematic, not the actual diagram. So initial mass, let's say it is M. So with time degradation will happen, the mass will reduce. So let's say that mass will be MP. Let's call the initial mass as M naught. So this will be at T equals 0. Let's say this is at T equals T. So the rate of change, that is dm by dt of the mass within a landfill. So we are saying that it is first order. So first order means it will be linear. So, or you can also say along with first order being first order, it means the power of the time will be 1. So here let's say we have minus k into t. So here we can see this is also first order and first degree. So dm by dt is minus kt. So sorry, this will be minus k into m, not t. So the rate of change of mass, that is dm by dt within a landfill, is proportional to the mass of waste within the landfill, and we have added a proportionality constant. So dm by dt will be proportional to m. Then we will add a constant, so it will become dm by dt equals minus k into m. This is because with time, the amount of waste within the landfill is reducing, henceforth the minus sign. So let's take m on one side. So dm by m equals minus k dt. So now we have two differentials on one side, so we can integrate. So initial mass m naught, initial time 0, final time t, and final mass, let's call it m of t. So this will be ln of m. The limits are m naught to mt. Here this side we will have minus k. The integration of dt will be t. So t from 0 to t. So integration of 1 by m will be ln. So this will be ln of b minus ln of a will be ln of b by a. So mt by m naught equals minus k t minus 0. So this is minus kt. So let's take ln on one side. So we can take exponential. So that would make it mt by m naught equals e power minus kt. So we can get mt as naught into e power minus kt. So this is the amount of mass that will be present in the landfill mt at a time instant of t, given that the initial mass is m naught and the rate of change is k. So I think someone answered A, so that is not correct. That should be the mass of waste that has got degraded. So that would be basically, you can say m naught minus m of t. So this will, initial we will have m naught, mt will be at certain time instant. So what will be the difference? That will be the mass that has got degraded, or you can say decayed. So this will be equal to m naught into 1 minus e to the power minus kt. So that is for option A, the explanation. And the answer will be mt equals m naught e to the power minus kt. This is the way it is derived. So you can also remember the equation directly. So option D is the correct answer. So I hope this was clear. I'll just wait for a few seconds if someone has any doubts. In case you don't have any doubts, we'll move on. So I hope this was clear. So option D is the correct answer. MT equals m naught e to the power minus kt. So you can refer to the second lecture of this week. So this is as per the for the gas production. So it follows the first order exponential decay model, which is commonly used. We can use other quadratic or even cubic models, but this is the most commonly used model. So it will be the remaining mass of a batch of waste. So that is empty. How to solve an exponential? Okay, just to give some basics. So just let me explain this first. So initial mass of waste m naught, and depending upon it operated with e power minus kt. So that will give us the remaining mass of the. So let's say we have something like ln of a, some number a equals k. So now we want to find k. So how will we do that? We'll just take the exponential on both sides. So that would become e power ln of a equals e power k. So the property is that e power ln of x is nothing but x. So this would become a equals e power k. Or if this was, let's say this was 1 and this was 2. So here what we did was we took exponential. Now we can again convert it back to 1. So how will we do that? We'll take the ln. So that will be ln of a equals the ln of e power k. So the property is that if you take the ln of e to the power x, is basically log of e to the e to the power x. So the base is same, the number is same. So the power simply gets transferred to the front. So this becomes x. So this will become ln a equals. So this is e is already here due to natural log, and we have the power. So the power will come to the front. So ln a equals k. So we can convert 1 to 2 and 2 to 1. So was this clear? Yeah. So moving on to question number 5. So waste Portland cement concrete has a market for which of the following use? So options are boiler fuel and mulch, recycled in new hot mix asphalt, replacement for crushed stone as a raw material, and none of these. So let's take each of the options one by one. So for getting used as boiler fuel or even mulch, you need the element or the waste to be organic nature. Whereas Portland cement concrete is inorganic, so A cannot be the answer. So for this, usually we use wood. Then we have recycled in new hot mix asphalt. So asphalt is nothing but the American word for bitumen. So bitumen, concrete, they are not the same thing. So we cannot use a concrete directly with asphalt. So as a material for asphalt, so you can remove B also. So finally, we are left with replacement for crushed stone as a raw material. So concrete has a high compressive strength. And what do we require with stone? So one of the primary requirements for using stone as a raw material or aggregate as a raw material is to provide the required compressive strength or the tensile strength, depending upon what we need, what is the application. So here, let's say we are concerned with compressive strength. So concrete can easily provide that. So we can use it for replacement for crushed stone as a raw material. So option C is correct. So once we have the dislodged cement concrete, we can crush it in a crusher and use it as raw material for replacement for stone. Because for stone, we need to do mining of virgin materials. So we can reduce the mining and depend upon the used concrete. So the answer is option C, replacement for crushed stone as raw material. You can refer to the 5th lecture of this week for this question. So Portland cement concrete is a high volume, low value material. So can be used for crushed stone as a problem. Moving on to the next question, question number 6. So which of the following is not a market for waste gypsum drywall? So the given options are Portland cement production, boiler fuel and mulch, agriculture and construction material. So can I quickly have some response for this? Question 6. So I think someone has responded B. So, yeah, Soumya has responded B. So let's discuss. So yeah, waste gypsum drywall. So the primary component of this is gypsum. So gypsum has number of applications. So one of the primary applications is it is used in Portland cement. So Portland cement has a property to set rapidly. So we add some gypsum so that we can delay its setting. So that is one of the applications. So A is correct. It is a use of gypsum. Then we have boiler fuel and mulch. So this is where we need organic compound. Gypsum is not organic, so we cannot use for this. Agriculture, gypsum is used for soil stabilization. It is just mixed with soil so that we can stabilize it. So C is also correct. And construction material, we can use it because we are using it in cement, so indirectly it contributes to construction also. And we can also use directly gypsum, so we can crush it down and again convert it to drywall and plastering material. So D is also correct. So here we are concerned with which of the following is not a market. So boiler, fuel and mulch we cannot use. They are the primary material that will go in use is wood. So option B. So option B, boiler, fuel and mulch. You can refer to the 5th lecture of this week for this question. So where all gypsum can be used? So it can be used for new drywall, cement production, agriculture and construction material. So moving on to the next question, question number 7. So which of the following is a duty of the local authority for handling C&D waste according to Solid Waste Management Rules 2016? The given options are monitoring the implementation of rules by the concerned local bodies, keeping the C&D waste within the premise and handing it over to the authorized processing facilities, incentives, provision for the products developed from C&D waste, and keeping track of the generation of C&D waste and establish a database and update it once in a year. Can I have some response for this? Give a few seconds. We don't have a response. Let's see the answer. No issues. So here we are concerned about the local authority as per the Solid Waste Management Rules 2016 for the C&D waste. So let's go through each option one by one. So monitoring the implementation of these rules by the concerned local bodies and the competent authorities. So yeah, this looks logical. So A is correct. So this is a duty of the local authority. So local authority is nothing but the municipal body. Takes care of the waste. So then we have keeping the C&D waste within the premise or get the waste deposit at the collection center or hand it over to the authorized processing facilities. So we are talking about keeping the waste within the premise, getting the waste deposited at the collection center. So this cannot be the duty of the local authority. This is the duty of the waste generator. Because local authority will oversee the process, but they won't be doing micro handling of the process. So here we are talking about keeping the waste within the premise. So that is the duty of the waste generator. So this is not a duty of the local authority. Then we have incentives should be provided for utilizing the products developed from C&D waste. So this is because we need to develop a market for C&D waste and make it sustainable in the long run. So this is also done by local authority. So C is correct. Then we have keeping track of the generation of C&D waste and establish a database and update it once in a year. So this is also the local authority does. So here we are talking about which is not a duty. So A, C, and D are duties, and B is not the duty. So the correct answer is option B here. So B is not a duty, but it is the correct answer. So B is the duty of the waste generator. This should be remembered. So here we can see, so keeping the C&D waste within the premise or get the waste deposit at collection center or hand it over to the authorized processing facilities. You can refer to the third lecture of this week. So here you can see the duties of the local authority. So I think they should keep track of the generation of C&D waste and establish a database once in a year. So I think this was one of the options. Then we had incentive should be provided for utilizing the products developed from C&D waste. So this was another option. And I think we had one more option, which was about the local authorities. Was the first question, monitoring the implementation. So I think this is like giving detailed directions with regard to proper management and in accordance with the provision of these rules. So this is one of them. So I think there may be other slides also, so you can refer to those slides also. So I put up some 2, 3 slides where the duties were there. So there may be other slides as well. This cannot be exhausted. So moving on to question number 8. So this is a poll. So we have some compliance criteria and we need to match them with the time frame for the implementation according to the 2016 rules. So the compliance criteria is given: formulation of policy by state government, identification of sites for collection and processing facility, commissioning and implementation, and monitoring by the State Pollution Control Board. So the given choices for time frame are 24 months, 12 months, 2 to 3 times in a year, and 18 months. The options have been given. So you can answer it in the chat as well as the polls. I'll just drop the poll. Just view it. Give you maybe 2 minutes for this, then we will discuss the answer. This is we have one response for the second option. Wait for few more seconds, then we'll discuss the answer. Okay, we will discuss the answer for this month. So here we have the different compliance criteria and their time frame. So firstly, what will happen? So firstly, we will form the policy. So we need to have certain rules, certain guidelines in place. So that will be done by the state government. Then we will identify the sites. Then we need to construct the site. Basically, it is called as commissioning of the site. So after construction, only commissioning can happen. Implementation will happen, and finally, after it is commissioned, monitoring will happen. So policy by the state government, it should be formed in less than 1 year time. That is around 12 months. So one will go with 2. Then we have identification of sites. So that should be done within 18 months. So 2 will go with 4. So these are as per the solid waste management rules. So these are basically guidelines. So then we have the third one, that is commissioning and implementation. So for this around 2 years of time is given. So that is 24 months. So 3 will go with 1. And finally for 4, monitoring by the State Pollution Control Board. So monitoring should happen at least every quarter, that is every 3 months or 4 months it should keep happening. That is 2 to 3 times a year it should happen. So 4 will go with 3. So we have 2, 4, 1, 3. Let's see. So 2, 4, 1, and 3. That is in option B. Option B is correct. So 1 went with 2, 2 with 4, 3 with 1, and 4 with 3. So you can refer to the third lecture of this week for this question. Option B was correct. So here we can see the time frame of implementation for different compliance criteria. So formulation of policy 12 months, identification of sites 18 months, commissioning 24 months, and 3 to 2 times a year we do the monitoring by the State Pollution Control Board. Moving on to the next question, question number 9. So which of the following is a duty of the Bureau of Indian Standards and Indian Road Congress for handling C&D waste according to the Solid Waste Management Rules 2016? So providing suitable sites for setting up of the storage, processing and recycling facility, preparation of operation guidelines, preparation of the code of practices and standards, and none of these. So we are concerned about Bureau of Indian Standards and Indian Road Congress. So Indian Road Congress is responsible for supervising the construction and design of roads. So suitable sites for setting up of storage, processing and recycling facility for C&D waste. So this cannot be a duty of Indian Roads Congress logically. Preparation of operational guidelines relating to environmental management of C&D waste. No. So this can be a duty of maybe PCB or SPCBs. Then preparation of code of practices and standards for the use of recycled materials and products of C&D waste in respect of construction activities of road. So this can be a duty of the IRC, also Bureau of Indian Standards. So why BIS is involved? Because we are preparing codes and standards. So there BIS will come up, and when we need to supervise the construction, so there how to use these materials in the C&D waste in the construction industry. So there IRC will come in. So that is the duty of these two bodies. So option C is the correct answer. So preparation of code of practices and standards and the products of C&D in respect of construction activities. So you can refer to the third lecture of this week. So we can see standards and practices pertaining to construction of roads and standards and practices for the C&D waste in respect of construction. So moving on to question number 10. So leachate generation data from the help model can be used for following component design. So pump design, slope of the liner, leachate storage tank, geonet and geotextile design. So this is a multi-choice correct question. So leachate generation data obtained from help model. So how much leachate is getting generated, we know that. So more leachate, we will need a powerful pump to pump it out. Less leachate, we may not need a powerful pump, or we can have multiple pumps for more leachate. So pump design will matter. A. Then we will have the slope of the liner. leachate storage tank and pond design. So yeah, this will also get controlled from leachate generation, because more the leachate, the larger volume the storage tank should have. So C is correct. Similarly, more the leachate, we should have a better quality, more thickness of the geotextile that we are using in the liner. This is option B. Although B is also controlled in some aspect depending upon the leachate generation data, but it is not a direct impact. So it will go into the liner design part. So A, C, and D are correct. So option A, pump design, option C, storage tank, and option D, geonet and geotextile design. So here we can see the leachate generation will control the storage tank, pump design, and geonet and the geotextile design. And the slope of the liner, that was one of the options. So that will go in the design of collection system. So it is like a sub-component, not a direct component. Moving on to the next question. So this is a poll. So which of the following statements are true for conventional and bioreactor landfills? So total gas production of bioreactor is greater than conventional landfill. Total gas production for both are equal. The waste decay rate of bioreactor landfill is greater, and the waste decay rate of bioreactor is lesser than conventional. I'll give you 2 minutes for this. You can answer it in the chat. Okay, B and C. So we have 2 people here. I'll wait for a few more seconds. Then we can discuss the answer. Okay, we'll discuss the answer for this one. So we are comparing conventional and bioreactor landfill. So bioreactor landfill is nothing but we will recirculate the leachate within the landfill to enhance the microbial activity so that the decomposition of waste is faster and the time of reaction that is taking place reduces. So depending upon the reaction rate, so let's say conventional landfill graph will look like this. In bioreactor, it will go up higher because it has a higher rate, but since it has a higher rate, it will come down also faster because the waste or the organic content that is present in the waste will get degraded out. So it will go down quickly. But a conventional landfill, the reaction will keep going on for quite some time. So if we see the area, let's say this is AC and this is AB. So area under conventional and area under biological. So the areas will almost be the same because the amount of waste is same. So the areas will be same. Although, because why it happens is there will be a certain point where they will intersect. So bioreactor will go down quickly, but conventional will keep on extending till a long amount of time. So it kind of, so this extra portion that is here gets compensated by the more time that is taken by the conventional landfill. So the areas will be equal. So what is area? Area is nothing but analogous for the total gas production. So the total gas production will be equal for obviously identical waste and landfill characteristics for both the bioreactor and conventional landfill. So option B is correct. Then we need to compare the decay rate. So obviously, since we are recirculating the leachate, the decay rate of bioreactor landfill will be greater than the conventional landfill. So option C is correct. So I think Soumya answered B and C. So good. So B and C are correct. Total gas production is equal for both the bioreactor and conventional landfill. And option C was waste decay rate for bioreactor landfill will be greater than the conventional landfill. You can refer to the second lecture of this week for this question. So here we can see the graph of the gas rate and time versus time. So here we can see they are intersecting here. So this is not the full graph. So bioreactor will go down quickly, but conventional will keep on extending. So the areas will be same, but the decay rate of bioreactor landfill will be much faster than a conventional landfill, but the areas will be same. So you can remember these 2 facts. So moving on to the next question, question 12. So what are the duties of construction and demolition waste generators according to Solid Waste Management Rules 2016? So collection, segregation, and storage. Comprehensive waste management plan covering the segregation, storage, collection, reuse. Ensuring that there is no littering, and plan for collection transport either through own resources or by appointing private operators. So what should a waste generator do? I think we have some response. So A and C, okay. So when we are a waste generator, we will collect the waste, segregate it, and store it. So that seems obvious. So A is correct. So second is developing a waste management plan covering the segregation, storage. So this should be the duty of the private operators, or sometimes even the local authority should take care of this. So comprehensive waste management plan, the private operators that do the processing of the waste, they will do. So B is not a duty of the waste generator. Ensure that there is no littering and deposition so as to prevent obstruction to the traffic. So C is correct. So the waste generator should take care that the waste does not get littered. It should be properly stored at one place. It should not cause any obstruction to the traffic or the drains. So proper storage should happen. So C is correct. And plan for collection, transport, processing either through own resources or by appointing private operators. So this is the duty of the local authority, not the waste generator. So D is not correct. So A and C are correct. So option A, collection, segregation, and storage, and ensuring that there is no littering or deposition or obstruction to the traffic or the public. So you can refer to the third lecture of this week for this question. So these are the duties of the waste generators. So they will be responsible for collection, segregation, and storage. So ensure that it does not get mixed with this waste and it is disposed separately. Should be within the premise and it should be handed over to the authorized facilities, and there is no littering and deposition or no obstruction to traffic or public or the drainage system. So these are the multiple duties of the waste generators, the people or the other institutes which are producing the waste. So moving on to the last question, question 13. So which of the following are the duties of State Pollution Control Board for handling C&D waste according to the 2016 rules? So preparation of operational guidelines related to environmental management of C&D waste management, and preparation of annual report with special emphasis on the implementation status of compliance and forwarding this to CPCB before 31st July, forwarding annual compliance report to central government before 30th August, and granting authorization of C&D waste processing facility as per the rules after examining the application received. So how does this work is, so we will have the local authorities. So they will be supervised by the State Pollution Control Board, and the different state pollution control boards will be supervised by the Central Pollution Control Board. So this is the organizational hierarchy for waste management. So the preparation of operational guidelines related to environmental management of C&D waste. So this will be done by the Central Pollution Control Board, not the State Pollution Control. Preparation of annual report with implementation status of compliance and forwarding this report to CPCB before 31st July. So yeah, this is correct. So this is a duty of the State Pollution Control Board. So they should make an annual report every year, and it should be about how the rules were complied, and this report should be forwarded to CPCB before 31st July for each financial year. So financial year will be from, so it will be from 1st April to 31st March of every year. So this is the financial year. It is different from the calendar year. So forwarding annual compliance report to central government before 30th August for each financial year. So here we can see the state pollution control boards. So they will give the report by 31st July to CPCB, and then CPCB forwards it to the central government within 1 month. So this is a duty. So option C is a duty of the Central Pollution Control Board. So it will receive the reports from state pollution control boards and will forward it to the central government within 1 month. So A is not correct, C is not correct. These are duties of CPCBs. So B is a duty of state pollution boards, and then granting authority for C&D waste as per the rules. So yeah, D is correct. So option B and option D are correct. So option B, preparation of annual report and forwarding it to CPCB before 31st July and granting authorization for C&D waste as per the rules after examining the application received. So you can refer to the third lecture of this week. So here we can see the slide. So implementation of these rules, granting authorization, preparing annual report and forwarding it to the CPCB before 31st July. So this was the last question for today's session. If you have any doubts, you can ask, else feel free to log on. So thank you everyone for attending the session. We'll see you next week. I'll wait for maybe 1 more minute. If anyone has any doubts, then we will close the session. Yeah, thank you. I don't think anyone has any doubts, so we'll close the session. Thank you for attending the session. See you next week.